So good morning. Today's lecture will be about the partial fraction expansion, or as a shortcut, PFE. So the readings for today, in Wednesday, page 104 to 106. And today also is the due date for homework number 7. So everyone should be submit this by today. Then in Friday, reminder there's no class. And in between next week is also spring break, so no classes. Spring break. So next week there will be no classes as well. Okay, then you can again enjoy the spring break starting from today. Monday, after the spring break, which is the readings between page 106 to 108, and also it is the due date for homework number 8. You can start answering homework number 8 after today's lecture. And so you have also after Friday, or you have after the spring break. So I'm not expecting you during the spring break to do anything. You can just relax. So homework number 8 will be on the Monday after the spring break. While Wednesday, the readings on Wednesday, page 131 to 134. And of course, the important table is table 3.1, 3.2. In page 96 and 97 of the textbook. So these are very important. And then today or this week there will be no office hours. So if in case if you need to see me, send me an email. We can make a Zoom meeting, or we can just solve your issue. Okay, an example about the partial fraction expansion. Well, the overall idea is whenever we have biproper or improper, we need to convert this to strictly proper. So if the function is not strictly proper, we will use long division. And we did long division last lecture, and let's do more examples about this. So we have, let's assume we have x of s equals to 6s cubic plus 4s squared plus 8s plus 6 divided by s squared plus 2s plus 1. So we see here the order of the numerator 3, the order of the denominator is 2. So we have m equal 3, n equal 2, so m larger than n. Then this is not strictly proper. So what should I do? Use long division. That's what we will do every time. How to do long division for this one? We know the long division, which is s squared plus 2s plus 1. This is the denominator, while the numerator is 6s cubic plus 4s squared plus 8s plus 6. How can I do the division? Start from the highest order. The highest order is 6s cubic. Divided it over the highest order of the denominator. So the highest order of the numerator divided by the highest order of the denominator. So 6s cubic divided by s squared, so it will be 6s. Now, you can do the multiplication. 6s times s2, 6s cubic, plus 2s times 6s will be 12, s squared, then plus 6s times 1, plus 6s. Then, do the subtraction. Okay, we know these kind of divisions or long division. Then let's do the subtraction. 6s subtracted from 6s cubic, they will cancel each other, so it will be 0. Now 4s minus 12s, we will subtraction. 4 minus 12, negative 8. So it will be here negative 8s squared, then 8 minus 6, which will make it 2. So plus 2s plus 6. Now, The next thing is, look, is it strictly proper, this function, or is this order lower than this order of this one? No. Then let's continue. How to continue the division? Look at the highest order, negative 8. Negative 8s cubed squared divided by s squared, it will be negative 8. Now let's do negative 8 times this function. So negative 8 times s squared, negative 8s squared, negative 8 times 2s, negative 16s, negative 8 times 1 times 1, negative 8. Then let's do the subtraction. So the subtraction, basically, negative s and negative 8 and negative 8 will cancel each other. 2 minus negative 16 will make it 2 plus 16. Then the answer will be 15s. 6 minus negative 8, which is 6, negative will make it positive. 6 plus 8 will be 14. So plus 14. Now, look at this. Is this one order lower than the denominator? Yes, it has second order. Then we will stop. So the overall function, x of s, can be written to be as, look at the 6s minus 8 plus the remainder 12s plus 14 over the numerator, which is s squared plus 2s plus 1. So in other words, this is, we call it quotient. This is remainder. Then it will be as quotient plus remainder over the denominator. Okay? Now, after that, I'm ready to do what's the partial fraction expansion. So if we need to do Laplace inverse, for example, for 6s, this is equivalent to 6 delta bar delta prime of t. Negative 8, this is equivalent to negative 8 delta. Well, how can I do Laplace inverse for this one? It is not easy because we have s squared plus 2s plus 1. So what should I do? Even though I can say the denominator is basically s plus 1 all squared, but the thing which is, I have a problem in the denominator, 18s plus 1 plus 14. Okay, so what should I do? We will use partial fraction expansion. Partial fraction expansion, basically, what we will do is convert this one to be as c1 over s plus, for example, call a p1 plus c2 over s plus p2, something like that. Then after that, we can convert this to, or we can do Laplace inverse in an easy way, because this will be c1 e power negative sp, or actually I can put it up negative sp1 plus c2 e power negative s p1t negative p2t, something like that. That's how we do Laplace inverse, because according to the table, 1 over s minus a, this will be t power a, and don't forget times u of t times u of t. That's according to the tables. Let me just scroll just to show you guys. In the table, 1 over s plus a, something like that. Okay? E power negative a, u of t. Then here, let's go back to the notes. Then here, c1 over s plus b, s1 plus b1 plus c2 over s plus b2. This is equivalent to c1 e power negative b1t, u of t, c2 e power negative b2, t u of t. So that's the overall idea. Basically, we need to convert this to a format, and that can allow us to apply partial fraction expansion. Now, let's discuss what does partial fraction do, or how can we do it. So the first thing that we need to figure out, partial fraction expansion is applied only on strictly proper. If not strictly proper, then what we will do, long division, like what we did in the previous example. So before doing any partial fraction expansion, you need to make sure the first thing is strictly proper. So let's assume we have x of s equals n of s, which is the numerator over denominator of s. So we need to make sure that, or we have case 1, if d of s, or I would say n of s, if n of s has higher order than d of s, so it is not strictly proper, it is not strictly proper. So what we will do, long division. Then we will convert it to be strictly proper. So the final answer, x of s, will be the quotients plus the remainder over the denominator. So this one, of course, will be strictly proper. After that, I can apply the partial fraction. So that's the first thing. The second thing, which is we need to rewrite d of s with its roots as s minus p1 times s minus p2, etc. times s minus pn. So the overall idea, we would like to make it as a product. How we can? First, we will say d of s equals 0, then find the roots. Then you can get s equal to, for example, p1, p2, until pn. Then after that, we can rewrite this to be in this format. So, step number 3, x of s will be like this. X of s will be n of s divided by s minus p1 times s minus p2, etc. times s minus pn. That's what we did. And here we need to make sure it's strictly proper. Again, if not, do the long division first. So we will convert partial fraction expansion method says we will convert this to be as c1 over s minus p1 plus c2 over s minus p2, etc. until cn over s minus pn. That's, we will convert this into be product. It will be as a sum of each term alone. This is a method, it's called partial fraction expansion. Then, we know what's p because it's the roots of the numerator, of the denominator. Now the next thing, which is we still need to figure out, which is how to find c's. How to find c's. c1, c2, up to cn. How to find this? We can apply, this is general formula rule that you need to figure it out, or need to either memorize it because we will use this a lot. Ci, such that I can be 1, 2, up to n, will be the limits of s minus pi associated with the pole times x of s, and when s goes to pi. Okay? Such that if we need to say to calculate c1, c1 will be the limits when s goes to 1 of s minus p1 x of s. If we need to calculate cn, cn will be the limits here when s goes to p1. The limits when s goes to pn, s minus pn x of s. Then we calculated c. If we can calculate all of c's and split this function into partial fraction expansion, then we can do Laplace inverse easy, because the Laplace inverse of, for example, c over s minus p, this is equal to c e power pt u. That's it. Okay? That's based on our answers. Then, that's how we can calculate, or can calculate everything related to do the first thing, to do the partial fraction, or in order to do the partial fraction, we need to make sure, is it strictly proper? Yes. Let's go to the next step. Now, do the long division. After that, the remaining parts, that after we do the long division, or the strictly proper parts, we will make partial fraction expansion by looking at the denominator, find the roots, then we will make it as a product, then splits each term alone, 1 over S or C1 over S minus P1 or C2 over S minus P2, etc. Then we need to calculate C's. After calculating C's, we can do Laplace transformation inverse and easily. Okay, any question about this procedure?
Can it be a negative on the ET?
It is S minus P. If it is, for example, C over S plus P, then it will be C equal negative P. So it's depending on, we will say S equal P, therefore we put P here, S equal negative P, therefore we put P. Yes?
What do you do for repeated roots?
Repeated roots, yes. This will be, we will discuss this also in today's lecture. So first now here, I'm assuming no repeated roots. For repeated roots, I'm going to talk about this after discussing an example first, to make sure we understand this, then we will go to the next step. Any other question? Let's try this example. Let's do partial fraction expansion. Even like we can do Laplace transformation for Laplace inverse. X of S equal S plus 2 over S cubic plus 4 over S squared plus 3S. Now, is this one strictly proper?
Yes.
Yes. So, I don't need to do the multiplication. That's great. And the next thing, which is, look at the d of S. D of S, which is S cubic plus 4S squared plus 3S, will make it equal to 0. Let's find the roots. So after calculating the roots, it will be S squared plus 4S plus 3 equals 0. You can use the general formula to find it. So S equals 0, then we will realize S equal negative 1 and negative 3. So if we need to plot the poles and zeros, then we can say like the poles, there is pole at 0, pole at negative 1, pole at negative 3, and look at the zeros. Zeros S equal 2, this is 0, then negative 2. So here at negative 2 there is 0. That's if we need to plot the poles and zeros. Now, after I know the poles, I can rewrite this X of S to be S plus 2 divided by S, then S plus 1, S plus 3. Okay? Now I can guarantee that I wrote, at the second step, wrote it as products, not as a polynomial. Now, I can apply partial fraction expansion in easy way. So it will be C1 over S plus C2 over S plus 1 plus C3 over S plus 3. That's partial fraction expansion. The next thing is how to find the constants. Applying like this again, this is the overall term, which is when limit when S goes to Pi, S minus Pi times X of S. Now we need to calculate C1, so it will be limits when S goes to the pole associated with C1 is 0, when S goes to 0, so it will be times S, X of S. So it will be as S plus 2 over S plus 1, S plus 3. S and S cancel each other. Now substitute zeros. So it will be as 0 plus 2 over 0 plus 1 and 0 plus 3. So which will be 2 over 1 plus 3, which it will be 2 over 3. So C1 will be 2 over 3. That's it. That's the first one. Okay? How about the other constants? The other constant, to find C2, it will be limits. C2 is associated with S plus 1. Then when S equal negative 1, that's the pole, then it will be limit when S goes to negative 1 of S plus 1 times X of S, which is S plus 2, divided by S plus 1, S plus 3. S plus 1 and S plus 1 will cancel each other. Now I'm ready to substitute negative 1 on S, so it will make it negative 1 plus 2, divided by negative 1 times negative 1 plus 3. So the answer will be negative 1 plus 2 will make it 1. Negative 1 plus 3 will be 2. 2 minus 1, negative 1, it will be negative 1 half. Then we can say C2 equal negative 1 half. How about C3? C3 is associated with S plus 3. This means when S goes to negative 3. So S goes to negative 3. C3 equal limits when S goes to negative 3 then I would say like s plus 3 times sx of s, which is s plus 2, over s plus 1, s plus 3, then s plus 3 and s plus 3 will cancel each other. Substitute s as negative 3, negative 3 plus 2, divided by negative 3, then times negative 3 plus 1. So the answer will be negative 1 over 6. Then C3 equal negative 1 over 6. Now I'm not done yet. Go back, substitute this in x of s. Then this yields, I can write on the other page, x of s equal to C1, which was 2 over 3, 2 over 3 times 1 over s, plus, or it's actually negative, minus 1 half, minus 1 half, 1 over s plus 1, then minus 1 over 6 times 1 over s plus 3. Okay? We just substituted c's, because x of s was, again, C1, 1 over s plus 1, plus C2, 1 over s plus 1, so 1 over s, plus C3, 1 over s plus 3. Then I just substitute the c's. Then now I'm ready to do Laplace inverse. So Laplace inverse of x of s, which is going to be x of t. Then it's going to be the constant 2 over 3, 1 over s, which is u of t. Then minus 1 half, 1 over s plus 1, e power negative t, u of t. Minus 1 over 6, 1 over s plus 3, e power negative 3t, u of t. Using the property. Then I'm done. This is my final answer. That's how I did Laplace inverse. So you see here, like using partial fraction expansion will make the life easier. So I can use this table instead of going to do the integral, which will be too complicated. Okay? Now, how we can do this in MATLAB? We do this in analysis, how we can do it in MATLAB. So the first thing, this is x of s, s plus 2 over s cubic plus 4s squared plus 3s. That's x of s. So what I'm going to do, I don't need to do anything actually. The MATLAB can help me in doing the whole job. Can help me in doing the partial fraction as well. How? So what you will write in the commands, you will write like this is the numerator, which is 1, 2, the coefficient of the denominator, which are 1, 4, 3, 0. Okay? We know how we do this. Then how to find the partial fraction expansion? Basically, we will say that C and P, such that C is the constants, the coefficient of the constants, while P are the poles. Because we know it will be C over S minus P. That's what we used to do. That's what we mean by C and P. And we took it as a vectors because we're going to need the vectors. So the command that will calculate the partial fraction expansion is called residual. R-E-S-I-D-U-E of numerator, then command denominator. The order is important. Numerator, then denominator. Don't flip between. Don't flip. So what will happen? The MATLAB will give you the answer. When you put these commands, it will give you the answer. So it will give you the simulation results. So the simulation results will be, for example, C will be like, I can write it as a table, and P as a table. So it will be C, it's negative 0.1667. When you try this example, it will be like this. Then the other one, which is negative 0.5000. Then 0.667, while P, you will see negative 3, negative 1, 0. Okay, how can we translate this into the things that we find? So the first thing here, the x of s is actually C over S minus P. Okay? So we can say that, or we can write it, x of s as it's shown. X of s will be negative 0.1667 times, or divided by s minus p minus negative 3. Okay? Then minus 0.5 times or divided by s minus negative 1 minus, or actually positive, plus 0.667 divided by s minus 0. Okay, so what should I do? It will be as negative 0.1667 over s plus 3 minus 0.5 over s plus 1 plus 0.667 over s. Now, is this the same as what we got before? It's actually similar. Why? Before we got, which is, it was 1 over 6 over s plus 3 minus 1 over 2 s plus 1 plus 2 over 3 1 over s. And you can calculate negative 1 over 2, this is minus 1.5. Negative 1 over 6, this is negative 0.66. 2 over 3, this is 0.6. Then we get the same answers. That's it. So after that, you can do the Laplace inverse again, which will be as negative 1 over 6 equal to negative 3t u of t minus 1 over 2 equal to negative t u of t plus 2 over 3 u of t. Okay, does this make sense? Okay, so we can do it using MATLAB. You can do it using Handle. So we know both ways. Of course, MATLAB will make your life easier, but I mean here just to show you how we can demonstrate this. So again, you are required to know both ways, which is using the MATLAB and using the Handle tool. Now we have another thing, which is impartial fraction expansion, which is your colleague asked about it, which is how about if there is repeated roots? What should I do? So here is repeated real poles. If there are repeated poles, then the partial fraction expansion to calculate CI or how to do it will be different. It will not be the same as we know before. So how we can deal? Let me just give you this demonstration. It's if we have this function f of s as a of s over s minus p power n. Assuming this root is repeated n times. It can be 2, 3, 4, etc. Like s plus 1 all square or s plus 1 cube or s plus 1 power 4, whatever. So how can we do the partial fraction expansion? It will be as k1 over s minus p power 1 plus k2 over s minus p power 2, and we will keep adding the power until reaching k power m, km sub m over s minus p power m. Okay? So you will see we'll go higher orders with the polynomial. S minus p power 1 associated with k1. K2, s minus p power 2. K3, s minus p power 3, etc. until reaching the highest order, which is m, s minus p power n. Now, how to find k's? Now we know how to find the poles, or how to do the partial fraction. Now the other thing is to calculate the k. So ki will equal to this formula. You need to either memorize it or you need to write it in your notebook, but we will use it. So it will be 1 over m minus I factorial, and we know factorial, right? Like 3 factorial is 3 times 2 times 1, 4 factorial 4 times 3 times 2 times 1, right? Something like that. Then the derivative of order m minus I divided by ds power m minus I of s minus p power m f of s. Then after that, this derivative will be s equal to p. Okay? So again, you need to write this in your note sheets because we will need to use it. Okay? It's very important for you. How to deal with this? Let's give an example so we can get a better understanding. F of s equals 2s plus 1 over s plus 2, or I would say s plus 4s plus 4. Okay? Now, the first thing, is this strictly proper? Yes, it's strictly proper. Let's look at the roots. S plus 4 equal to 0. This is actually, the roots S will be negative 2, negative 2, right?
Is that meant to be S squared plus 4S?
Yeah, it's, yes, S squared, right. I'm sorry, I missed this. S squared, right. So S will be negative 2, negative 2. This means S plus 4, S plus 2 times S plus 2, right? Which is repeated. S plus 2 all squared. Then we have a repeated situation. That's how I know I will apply this if and only if there are repeated. So, what should I do? I can rewrite f of s with the terms of poles as 2s plus 1 over s plus 2 all squared. Then I need to do the partial fraction of the repeated, which will be k1 over s plus 2 plus k2 over s plus 2 power 2. Because the first one k1 power 1, the second one k2 power 2. Okay? Does this make sense? Okay, so you understand how I did this? The next thing is how to calculate k. The general formula said here we have m equal to, then the general formula for ki will be 1 over 2 minus I factorial d of 2 minus I, the derivative of ds 2 minus I of s plus 2 squared f of s, then our target to substitute it when s equal to negative 2. Now s plus 2 squared times f of s, we need to do this, which is inside the brackets, which is s plus 2 squared times 2s plus 1 over s plus 2 all squared. This yields to be only 2s plus 1. Then ki as overall will be over 2 minus I factorial, the derivative 2 minus I over ds 2 minus I of 2s plus 1, then when s equal to negative 2. Now, I'm ready to find k1 and k2. k1 will be 1 over 2, substitute I as 1, 2 minus 1 factorial, the derivative of 2 minus 1 over ds 2 minus 1, 2s plus 1, then substitute it when s equal negative 2, then 1 over 2 minus 1, 1 over 1 factorial will be 1, because 1 factorial is 1, then it will be the derivative, the first derivative, 2 minus 1 will be 1, which makes it the first derivative of 2s plus 1, then substitute it when s equal negative 2, the derivative of 2s plus 1, 2s will be 2, 1 is 0, so it will be only 2. As a result, we can say k1 equal to. Okay? So just like a map. How about k2? k2 will be 1 over 2, substitute I as 2. 2 minus 2 factorial will be 0 factorial. 0 factorial is actually 1. Then the derivative of 2 minus 2, ds 2 minus 2. So 2 minus 2, this means 0 derivative. Then 0 derivative means the constant will remain as is. The function will remain as is. So it will be 2s plus 1, no change because 0 derivative. Substitute when s equal negative 2. So it will be 2 minus negative 2 times negative 2 plus 1. Then it will be negative 4 plus 1. Then it will be negative 3. So k2 will be negative 3. Now, I'm ready to find f of s, or to overall say overall. F of s, again, was 2s plus 1 over s plus 2 all squared. Then you can substitute it to be 2 over s plus 2 minus 3 over, like this, minus 3 over s plus 2 all squared. Now, I need to do Laplace inverse to find f of t. F of t, the Laplace inverse of this one is the exponential. So it will be as 2 e power negative 2t u of t. How about this one, the Laplace transformation of this one? Go to the table, find if there is s plus a squared. Here is the table. Look where is s plus a squared. You will see that t e power negative a t u of t. So it will be the same thing but multiplied by t. That's based on rule number 6. So let's go back and substitute it. It will be times t e power negative 2t u of t. Then that's it. So you realize for the repeated roots, The only difference is we just multiply by t for the other one. Okay, does this make sense? Any question? Now let's do another example. Like this one, which is, this example will include repeated and non-repeated, like 10s plus 8 divided by s times s plus 4 squared. So we realize here we have repeated here, but this one is not repeated. So here we have repeated, and which is at s plus 4, and we have non-repeated. How can I treat it, which is s? How can I treat each one? So the first thing, let's do the partial fraction expansion for each one and take into consideration every function. So the first one, s, I'm going to say c1 over s. Try to finish the non-repeated roots first. So the first non-repeated is only s. Is there any other non-repeated? No. Then plus, let's start with the repeated, which is s plus 4 will be k1 over s plus 4 power 1 plus k2 over s plus 4 power 2. Okay? Now let's do, to find the constants. How to find c? In order to find c, we'll apply the formula that we used to know before, which is c1 will be the limits when s goes to 0 with sx of s, because this is associated with s minus 0, it will be s. sx of s. So which is going to be as limit when s goes to 0, s times 10, s plus 8 divided by s plus 4 squared. So s and s cancel each other, substitute s as 0. This yields to be 10 times 8 over 4 squared. And the answer, I think, will be 80 over 16. So it will be 85. Now C1, we found it, as we know before, using the non-repeated roots formula. How to find the others for the repeated roots? Again, we will do the same formula that we used to do before. Here, we have m equal to. Then, we will say ki equals 1 over 2 minus I factorial d2 minus I over ds2 minus I s plus 4 squared times x of s, substitute when s goes equal to negative 4. That's our all formula. Now, let's see s plus 4 all squared times x of s, that is 10 s plus 8 over s squared plus s plus 4 squared. Then s plus 4 squared and s plus 4 squared will cancel each other. This yields to be ki equal 1 over 2 minus I factorial d2 minus I derivative over ds2 minus I. Then it will be as 10 times s plus 8 over s. Substitute this one s equal to negative 4. Now I'm ready to find k1 and k2. So k1 will be 1 over 2 minus 1, which is 1 factorial, which is 1, 2 minus 1 over ds2 minus 1, 10 s plus 8 over s, when s equal to negative 4. Then basically it will be as the derivative of ds, because 1 factorial is 1, the derivative of 10 s plus 8 over s. In order to make it easier, I prefer to say s over s and 8 over s. So it will make it as the derivative of 10 times 1 plus 8 over s. Substitute this one s equal to negative 4. Then the derivative of 1 will be 0 plus 8 over s will make it negative 8 over s squared. Then substitute on s equal to negative 4. Then it will be 10 times negative 8 times 1 over negative 4 squared, which will make it negative 80 over 16. And I think it will be negative 5. Then negative 5. So k1 equal to negative 5. Then next, I'm ready to calculate k2. K2 which is 1 over 2 minus 2 factorial. 2 minus 2 factorial is 0. 0 factorial is actually 1. Then it will be the derivative of 2 minus 2 over ds2 minus 2. This means 0 derivative. This means the 0 derivative of the function will be the same the function itself. So it will be 10 times s, or you want s plus 8 over s plus 8 over s. When s equal to -4, then it will be as 10 s plus 8, the same function itself. When s equal to -4, this make it 10 times -4 plus 8 over -4, then this yields to be -10. Then you will say k2 equal -10. After finding this, then the rest of the problem will be easy. How? We can say that x of s equal to 10, or actually equal to c1, which is 5 over s, minus k1, 5 over s plus 4, plus k2, which is -10 over s plus 4 all squared. Now how to find this? We can say x of s equal to 5 times 1 over s minus 5 times 1 over s plus 4 minus 10 times 1 over s plus 4 squared. And in order to find x of t, we will do Laplace inverse of x of s, which is going to be 5, 1 over s u of t, minus 5, 1 over s plus 4 equal -4t u of t, minus 10, 1 over s plus 4 squared. This means t equal -4t u of t. Because of the squared, we will need to multiply by 2. Okay? Then that's it. This is x of t, problem done. Okay? So it's just like a math. So I think today's lecture is more toward calculus other than sequence. Then, the other thing, which is, how about if we have complex roots or complex terms? Complex terms. What should I do? Assume we have f of s equal to a of s, or n of s, whatever, s squared plus cs plus b. Then, for some reason, when we calculate s squared plus cs plus d, we realize it will be 0. I'm sorry, it will be complex number. So s1 or 2, these poles will be as a plus minus j. So keep in mind, in real life systems, whenever we have a complex, these two roots must be complex conjugates. Complex conjugates. This means S1 equals to the conjugate of S2, or A plus JB equal to A minus JB conjugates. This is a must. If we have a real life or realistic system or closing system, then we need to have this. So how we treat this situation, f of s, when we do the partial fraction, it will be k1 over s minus the first root s1 plus k2 over s minus s2, or in other words, I can substitute them as k1 over s minus a plus jb plus k2 over s minus a minus 2. Okay? Because I substituted s1 and s2 as a plus jb as a minus j. Okay, how do we find this? We will not consider this as a repeat, of course. No, what we will do, we will do the same techniques that we used to do before. So basically, in order to calculate k1, it will be s minus a minus jb times f of s. Substitute when s equal a plus jb. How about to find k2? K2 will be s minus a plus jb times f of s when s goes to a minus j. Then you will realize a result, a nice result. K1 equals to K2 conjugates. This is a must. So when you will do your answer, You can check your answer. Is K1 as the same as K2 conjugate? If yes, then that's correct. Or in other words, you don't need to calculate K2. You can calculate K1 and say K2 will be K1 conjugate. And that's it. So you can calculate one constant and find the others from its conjugate. Okay, does this make sense? Any question? Okay, let's do one more example. Let's do this. These are the tables. And assume we have x of s as s e power negative 3s divided by s squared plus 4. So, what should I do? How can I deal with this problem? In order to do partial fraction expansion, we have a problem which is e power negative 3s. This is not as polynomial. So what should I do? We will assume x1 of s equal x of s e power positive 3s, just like as the opposite of this one. This yields x of s equal to x1 of s e power negative 3s. So as a result, we can rewrite x of s as this. It will be s over s squared plus 4 times e power negative 3s. And otherwise, this will be as x1 of s times e power negative 3s. So as a result, this yields x of s to be x1 of s will be s over s squared plus 4. So we will try x1 of s alone. Then after that, the final answer we will multiply by e power negative 3s. Okay? So that's the point, because we need to have a polynomials in denominator and numerator. If we have polynomials like exponential, this will create a problem. Then, in order to solve this problem, let's do it. We did this assumption. So let's do it for this function. After that, we will multiply by e power negative 3s. So how we do x1 of s partial fraction? So look at the denominator. This one is strictly covered, so it is good. So what we will do is s squared plus 4 equals 0. This yields to be s equal plus minus 2j. Okay? Then we can say x1 of s will be s over s minus j, 2j, j2, whatever, s plus j2. Okay? Then it will be c1 over s2j or j2, whatever, over s minus j2 plus c2 over s minus plus j2. How to find c1 and c2? To find c1, which will be x of s or s minus j2 times x1 of s, and we will substitute when s equal to j2, positive j2. So this yields to be as, I would say, like here is s minus j2 times s over s minus j2, s plus j2. Then this will cancel each other, and we'll substitute this one s equal to j2. Then it will be as j2 over j2 plus j2, which will make it as j2 over j4. Then the answer will be 1 over 2. This is c1. How about to find c2? c2, s plus j2 times x1 of s when s equal to negative j2. This make it s plus j2 times s over s plus j2, s minus j2, j2 cancel each other, and s equal to j2. So the answer will be 1/2. So we will say that c2 equal 1/2. Keep in mind, visualize c1 equals c2 conjugate. And there is no real part, so 1/2 equal 1/2. There is no imaginary part. Then our answer is correct. As a result, we will say x of 1 of s will be 1 over 2, 1 over s minus 2j, plus 1 over 2, 1 over s plus 2j. Okay? Then in order to find x of t, x1 of t will be 1 over 2 e power jt u plus 1 over t e power negative j, 2j, t, u of t. I can take u of t as a factor. Then it can be as e power j t minus e power negative t to t, j 2t, negative j 2t divided by 2. And this is equivalent to what? According to Euler formula. Cosine 2t. We know cosine e power j minus e power negative k over 2. Then this yields to be cosine 2t times u. Now this is x1. Recall our question is x of s equal x1 of s e power negative 3s. So this, according to time shift property, x of t will be x1 of t minus 3, u of t minus 3. Now we will substitute every t by t minus 3. So this yields x of t will be as cosine 2, then substitute t minus 3, u of t minus 3 times u of t minus 3. So as a result, it will be cosine of 2t, which is 2t minus 6, u of t minus 3 x of t. So we just go back to the origin and apply the shifts, then we define that. Any question? Okay, so that's it for today.